Thank you, Michael. Hope my mic's open. Yeah. Great. Okay. Eclipse SommR. Everybody's talking about collaboration through the industry, and that's why there's not just one company standing here, but two. Gerd Schäfer. Gerd, do you want to say a word?
Sure. Hi, I'm Gerd. I'm a software engineer and the CTO from ESL Labs. And I'm already feeling a little bit bad because we do not show code today. And I promise the next time the project will be represented by real developers. No offense, Tom.
Yeah, and my name's Tom Fleischmann, working for Gerd in the area of Volkswagen OS, especially what we call macro, taking care of hosting, for instance, containers on the embedded Linux QM side of things. Today we want to present you Eclipse SommR, one of our project proposals. Short agenda: background, some reasoning, then what is SommR, architecture outlook, and then as well a question mark on Rust, and a little bit of explanation and outlook following this. And we've seen it in the media, we heard it already today, there's really change ahead. Automotive is undergoing rapid transformation, especially in the term of software, and new ways of collaboration are opening up for car makers who are dealing with software, digging into software, going deeper, having developers there. That's exactly why we're here. So the whole thing is about enabling our developers to make their work more efficient with open source. And you need to be a bit patient with us as a car maker in this sense, because really it's a huge step for a car maker to go into this direction in your a terrain like the Eclipse Foundation. There is open source already being done by car makers, but it's really a big step for us here. And
ich wollte noch was dazu sagen. Okay, yeah, I'm also thrilled about this initiative and open source in the automotive world. Firstly, because we already use open source today, and I think it's kind of fair also to give something back to the open source world. And secondly, and this is a personal view, automotive software development is, and its well-known standards, is progressing very slowly. And I think it's time to bring in some competition into the automotive software game, and I think we just need more innovations and need to speed up our industry. Okay, so SommR is here, and it's yet another SommIP implementation. Bummer, yeah. Okay, for those who don't know, SommIP itself is yet another service-oriented middleware invented by BMW back in the days, and now it's an official AUTOSAR specification. SommIP offers RPC patterns like a request response, fire and forget, and also a notification mechanism and a service discovery. So it sounds very familiar, and I mean there are plenty of similar middlewares outside there. So why does it even exist? The idea was that it has to be scalable in the sense that it has to run on hardcore embedded ECUs that are operated by microcontroller as well as powerful Linux or QNX based machines. So it must run on really resource constrained systems, and that's why there is a new one. And that's also the reason why it sometimes feels a little bit bare metal, not that pretty, but it does what it does its job. There are plenty of implementations out there. It's part of every AUTOSAR stack, classic or adaptive. And there's also an open source implementation already, contributed by BMW to the Corvesa Alliance. So the question is, why do we need another open source implementation, Tom?
Here, one is really I'm going here some scope and high-level architecture on that thing. We really see the need for having that thing as a vendor-neutral solution, as one of the building blocks for our software-defined vehicle, where Gerd already mentioned it. it's on the core part of the ECUs, and we need it in bare metal performance, as one of the most robust things is the communication between our ECUs. That's pretty much the thing. So, scope of Eclipse SommR. Automotive grade, SommR stack for multiple programming languages, and we already seen today a couple of them, aiming to run on embedded Linux, supporting that directly, together with the tools for developers to actually generate that stack, because you need code generation in order to use it. It's not in a way as dynamic self-reflection as you have it for pre-development. For serious production, you need to apply code generation there. It's written in Rust, and we later see why. And for applications in Rust, in C++, because we still have a lot of them, as well as in Java.
Yeah, I think that this is also the biggest USP of the stack is that it's language agnostic. And I also want to stress this because this project is not meant to be a toy or research project, because it solves a problem we really face in serious development today. We built a very big integration ECU where we have the problem that we have different runtimes that come with different languages. I mean, if you think of services or applications that deal with networking of the car, then you need performance, then you go for C++ or Rust in the future. But for things like connected applications, you can choose productivity languages like Java or .NET. So you have the problem that you have different languages, and today we have to operate two SommIP stacks in one ECU, and you need dirty tricks to make this happen. Yeah, you have to use Linux network namespaces, for instance, and we were looking for a clean solution, and this is what SommR is about.
Yeah, and for us it's as well the first test drive into the open source collaboration on Eclipse SDV. It's a sub-headline. Gerd, high-level architecture.
Yeah, okay. So this is the most technical slide we have today. Okay, so the architecture comes with no surprise. There's one active component, the SommIP daemon, running its own process, and the daemon handles the service registry, also the connection handling to the other ECUs, and there's also an app handler taking care of all the applications that itself implement services, offer them, or have clients using other SommIP services. These applications come with a lib and also generated code, and we will support, as Tom already mentioned, Java, Rust, and C++. The communication between the app and the SommR daemon could be a Unix domain socket or a TCP socket. And yeah, as I said, a crucial part is the code generator. It is fed by Autosar XML as an IDL. I don't know if you ever came in contact with Autosar XML, but I think this would be another great open source project.
We're seeing here reactions in the audience. Not sure if that is to be seen for the people remote.
Yeah, so this would be a great project. I'm also aware of OEMs that came up with a proprietary language, but yeah.
And because the question came for every presentation that we had so far about security of consuming and the services, there are secure service-oriented specifications from Volkswagen to exactly address that concern, so I can take that question away. You'll find it in the QL-AHAs of the Volkswagen cooperation. And we sure need to deal with these. It fitted here.
Okay.
So, feature roadmap. The first thing, our initial contribution is planned for in a couple of months, in fall this year, so that we hope to be ready for the hackathon of the SDV working group and the projects, where we already want to offer the service discovery, the request response RPC things, the daemon in Rust, the client libraries and the code generator, together with the required documentations, examples, and the integration tests to get started. And Gerd?
Yeah, I also heard rumors that maybe Java will be included into the initial contribution to show interoperability. Okay, so next steps will to support more language bindings, and SommIP is a pretty new standard inside automotive. It's service oriented, so everything in the car must now be service oriented, and I think there are a lot of is a lot of misuse happening right now in the series projects, and it would be a great idea to have a design guideline how to come up with good service design. So this could also be part of this project, and we will definitely look into performance. This is always a topic. We are also dealing with optimizations at the moment in our running projects. So this is always crucial. And then we will do generated requirements coverage report potentially with OFT.
Yeah, you know, this automotive grade has something on it, and that very often means as well, Agile is really not enough, and it as well means follow a couple of processes, decent industry processes, and surely one of them is sure, know your requirements, track them along the process on the V model. You can do that in cycles of Agile development, but you need to provide a requirement coverage report, and best is if you build it with Jenkins or Actions for every continuous integration release you do. And therefore, it's pretty good to have that so that you can manage all your requirements as you manage a code base, and tools doing that and helping this are, for instance, a project I'd like to do, the advertisement here, like the Open Fast Trace project, as well an open source project, a requirements tracing suite helping you to show these tests are passed and these requirements due to the test are passed are already implemented in this piece of software. That as well belongs to being automotive grade, just one portion of it.
Okay, and as I already mentioned, I mean, this is neither a toy project nor a research project. This is meant to go into the car, so we will do everything to get it to serious production quality.
Just a brief look on Rust, and we already heard on it. Why Rust? Hype was solid. For all of you who has been in automotive for the last decade, automotive is full of hype technology. We're following pretty much every hype cycle if we can. That's not a wise thing to do. Therefore, we as well question ourselves, are we just following the next hype that's coming around the corner? Or is that a solid piece of technology that we're betting on for certain things? We have people here in the audience as well, very decent into Rust as well for safety, for future. But for us now, for that Eclipse SommR project, it's a brief check and answer for ourselves and for the audience why we've chosen Rust. And we are seeing clear benefits in general for robust automotive software, where the current focus really is on security, like isolation and stuff, connectivity, running on top of that for performance and stability. There's really a remark there. It's not a walk in the park to develop in Rust, but it's not the thing for building quick and dirty throwaway prototypes. That's definitely not the case. And the developers who started really digging into Rust, using it, they won't like to go back to C++. That's potentially as well a thing. So if you bring your team into Rust, it's potentially not the best thing to give them a lot of C++ projects afterwards when they are already seasoned and experienced in this. And on the next slide, we have some details of what it actually means to fight the borrowjacker. Or why Rust here? Gerd.
Okay. I mean, as you know, C and C++ are the dominant languages in automotive, and they are dangerous. And I'm allowed to say that because ESL Labs is mainly a C++ company, and we had our share of very, very nasty bugs caused by memory safety issues or concurrency. So for us, Rust is the next logical step to get to correct code, because concurrency and memory safety is built in and is checked by the compiler. And it's also very efficient. I mean, we do a lot of benchmarking performance-wise, and for our use cases, we do not see degradation of performance. So we invest a lot into Rust, and think that it has a good future inside of automotive software development. And there's also a lot of really mature libraries out there, like we saw the Tokyo I/O in the Microsoft demo, which we also use for networking stacks. So I mean, it's already there. It's going into serious production, and I think it's a great competitor for C++.
Yeah. And what to add here as well, for the hype thing as well, it's always good to have data to base decision on, and not just listen for what sounds cool. So we really made benchmarks on real production hardware. One of them you see above me, and the two straight lines on the bottom, that is the Rust implementation, starting up certain stuff, and the above thing, something else. I don't go into too much detail. So we're seeing here real clear data-based benefits on using this approach here for our systems.
And I just learned at lunch that we have a Rust evangelist here today.
So for everybody on site, he's hiding here in the middle of the audience, Florian Gilcher. So here. Perfect. Gerd initially said it. I definitely do not count anymore as a developer. That's long past. My spare time programming can't really come up to that. So for the next Eclipse SDV meeting, we will have our developers here because they are actually building the software-defined vehicle. That's for sure.
Questions?
I have a final slide.
Okay. Sorry.
As well, collaboration. So I changed this map of the software-defined car into the map of the software-defined vehicle, the first change. And we heard already from Michael Plugge in the introductory session, having all these links in automotive and the collaboration things, just as a teaser. The software-defined vehicle and the vehicle software as such has a lot of topics which we haven't yet covered, so there is more room for contributions into SDV, and I'm saying this now as a member of the SDV steering group, so there is way more to cover, as it is on the embedded line here, as it is on the security part, as well as the connections to the cloud and various other things. So there's more to come. Yeah, looking forward to it. Thank you.
Thank you.
Great. Tom and Gerd. Just give me the micro. I can save one way. I've been asked in the preparation of the event if there's something with Rust, and I was thinking, what? I was in a completely different thinking when I heard the first. I have heard of Rust before, don't get me wrong, but in that context, I was still thinking of a programming language. Any questions from the audience here? I start here and then I will go upstairs, right? Just.
Fitness workout today. Thank you for the presentation. I am surprised to have you guys. I'm very happy to have you guys in the first session here. Well, you mentioned that this is not a toy. You mentioned that you're working on getting the requirements, processes, and content right. We have Florian in the room from Ferris. So I guess, coincidence. I guess. Is it on the longer-term roadmap to get the safety certifiable, usable in a QNX system, for example, or etc. etc.?
I mean, some are not as the initial thing, because you've seen we're running on embedded Linux. So in order to cover the whole story for safety, there's more to do. For Rust in general, potentially Gerd, on safety.
I see another Linux, another Eclipse project there. I don't know. I mean, our main focus is are systems that are not safety relevant at the moment, like these huge integration platforms. And
Yeah. But there is activities ongoing throughout the industry to get Rust compiler safety certified. Many of you know that companies like Faro Systems are working on that. This is no secret to the industry. For that project, not.
By the way, the interruption was because the laptop decided to install an update. So, as usual, right, worst case scenarios.
We have some Microsoft guys here.
Yeah. Maybe it's running on Linux.
I see it.
The standard, I think, yeah, that's always right. It's the same. So on my way to the next question, I can ask one of the questions from the online session. What are the plans, if any, to support QNX, since Rust currently has no official support for QNX?
This we need to ask to the QNX people, I guess.
Understood. So then let me just ask one more, and then we will take this question. Would local communication with other SommIP implementations, like the Covesa implementation, work?
Locally.
You're the expert. I have no idea what local could mean.
The intention is that there is only this one stack inside of the system and supports all the other runtimes that maybe use different languages.
Over the network, it may make sense.
Yeah, over the network, of course. I mean, it's
the networking protocol.
It's some IP stack that should be interoperable with other stacks, sure.
Yeah, hi. You said this will have a code generator based on Autosar XML. So will you use an existing Autosar XML parser, or would you also write one in this project, which could be a larger code base than the SommIP stack?
True. But the code generator is also part of the project, sure.
Sorry?
I think
Code generator is also part of the project.
Yeah, and you will write one from scratch, parsing Autosar XML and building a meta model or whatever?
I think it's an existing generator that is adapted for this use case.
Okay. There's another online question. How does SommR differ from, for example, SommIP?
It's language agnostic. SommIP is only C++.
Okay. And then I have a question based on my Autosar experience. I'm not sure if that really would be, but maybe you can answer that but much better. Can a SommIP packet be converted to TCP IP packet? Also, what about CAN and or FlexRay?
SommIP uses either TCP or UDP, no FlexRay.
Yeah, that was, yeah. I just think we have the time. Why not answering all the questions here? But that was my assumption based on my personal Autosar experience from the past.
And potentially to mention this, for the design guidelines and pitfalls to avoid, there's potentially a chapter due for what to do with service communication and what is like not to do, you know, bridging and transforming things can be tricky of automotive protocols.
And thanks also from my side. Since we've been already talking about the other SommIP implementations and you mentioned them in the beginning, I'd like to understand what was the thought process and also the decision process in your way to SommR, not taking one of the open source implementations which are there and maybe implementing your ideas and maybe language agnosticity, what you just mentioned, into those projects, but start a different one.
As I said, we are facing the problem that today in this project we have a Java runtime that needs SommIP as well as an adaptive Autosar runtime, and the problem is solved by running two stacks in parallel, which is a problem if you want to run the service registry at SommIP. So you have to come up with this network namespacing stuff, which is kind of a hack. So we were looking for a clean solution, and that's what the SommR is about, yeah.
Yeah. I mean, that doesn't prevent that we're having a collaboration with the Covesa guys as well on the Eclipse SDV mailing lists or on theirs, trying to get interoperability suites or stuff done. So definitely within the community, collaborating with the existing projects. And sure, it implements an AUTOSAR specification. So there is work ahead, and as well community collaboration coming.
Okay, so I think there was one more question.
Thanks a lot. Thanks a lot for the presentation. I'm really excited to see the code. Will you also develop end-to-end profile libraries and secure onboard communication according to AUTOSAR? Just say yes.
I mean, it's already there. It's not open sourced yet, yeah. So I mean, we have to support secure SOA for sure. But yeah, maybe.
Okay, there's a slight chance.
I mean, you will see in the project on the dev mailing list, on the issues and tickets, on the code base, what's in, what's out, what we're discussing there, really where we learn how to work in the community with contents, feature requests. So, yeah.
But maybe that question also touches on a point which I think is quite important, right? So AUTOSAR is not open source. It's not open. That means the outcome, the results at the moment are only usable for AUTOSAR members. But there is a tendency to open up, right? I'm not sure if you've seen the latest presentations, but the AUTOSAR steering committees, the ideas at the AUTOSAR consortium to open up, to make AUTOSAR, at least to some extent, usable by open source projects. And I think projects like yours will also support and push this opening of AUTOSAR to be usable in open source projects. And I think that's a reasonable way, right? We see that push into open source. Software-defined vehicle working group is just one of the outcomes of this new approach, doing things, collaborating in the open. And I think that was recognized by AUTOSAR, and now they're looking for ways how this could be compatible, which is interesting because that seems that what we are doing here, let's say, make well-established organizations thinking, and AUTOSAR for sure is one of the biggest of them. And I think it's quite interesting to see that all they are now looking into what could they do to collaborate with open source. Maybe a final question, and then the last presentation before the break. Do you see a SommIP CNI bridge in future? I have no idea what CNI means, but maybe you can answer that one.
What, sorry?
Do you see a SommIP CNI bridge? I'm not sure what CNI means. So maybe for the online asks, reach out to Tom and Gerd afterwards. You again find our emails on the project website. They are committed to the project. And then, Container Network Interface. CNI stands for Container Network Interface. Oh. So is there a bridge between SommIP and the Container Network Interface?
So we're having a different project that takes care of containerization. Future candidates for SDV. We'll check and come back.
Good answer.
If we forget it, please post it on the development mailing list.
Okay, great. Thanks, Tom. Thanks, Gerd. Sure. Also for being available for the answers and questions.